So now let's take a look at a completely different shelled organisms, and that's our bivalves. Their line of symmetry is going to be completely different than what we saw with our brachiopods. So in our bivalves, let's just make a generic shell shape here, and say it looks like this. Say here's the hinge. If we were to take a look at both of these organisms, you're going to have to bear with me here. I am a horrible artist. What we would see is that the line of symmetry is actually parallel to the hinge, so that this shell is equal to this shell. So if we were to do what I like to call the brachiopod test, let's say you were to get this shell. Let's say you're going to get a shell that looks like this, and you only have one shell. This maybe kind of reminds you of a reminiscent shape of an oyster shell. Let's say there's the hinge. So let's do the brachiopod test. Remember, brachiopod shells have their line of symmetry perpendicular to the hinge, and if we look, this side of the shell does not equal that side of the shell. So I automatically know it's not a brachiopod. Right? So remember, our line of symmetry for our bivalves is parallel to the hinge. So that makes it one shell is mirror image of the other shell. And the next time you go eat some raw oysters, take a look at both shells, and you will indeed see that oysters are bivalves. One shell is mirror image to the other.